temperature-volume relationship. As volume increases, so does temperature. This is a directly proportional relationship. So we're going to utilize our equation when solving these problems. So for example, on page 12, it has a reminder here that we have to be in Kelvin, and then the equation is at the top. So step one is to read the question. It says, a gas occupies a volume of 200 milliliters at 0 degrees Celsius. What volume will it occupy at 100 degrees Celsius? So I'm at these two variables, so that's my volume 1 and my temperature 1. I'm looking for, it says what volume, that's my new volume, if it goes from 0 up to 100 degrees Celsius. So I've identified my variables. Volume 1 is 200 milliliters. Temperature 1 is 0 degrees Celsius, but we have to change that to Kelvin, so I would add 273, so that gives me 273 Kelvin. Volume 2 is what I'm looking for, that's my unknown. And temperature 2 is 100 degrees Celsius, so when I add 273 to that, I end up with 373 Kelvin. Okay. So there we go, that's step one. Step two is to use your equation. So I have volume 1 times temperature 2 equals volume 2 times temperature 1. I'm trying to solve for V2. So I need to move temperature 1 to the other side. Since I'm multiplying by T1, I would divide both sides by T1, and this cancels. So I now have this equation. Those of you using the proportion method are going to see that you need T2 over T1, because if I'm trying to change my 200 milliliters and my temperature goes up, then this would need to be greater than 1. So that would be the 373 Kelvin over 273 Kelvin. So T2 and T1. And now I can use my calculator to solve. 200 times 373 divided by 273 gives me 273. Hold on. Okay, gives me 273. And my kelvins cancel, so this is milliliters. Okay, in the rest of these, these are terrible significant figures, Miss Rogers. You're welcome. Yeah, you're right. So look, let's just assume 3 sig figs everywhere, okay? I'll go back and fix this for next year. So 28.0, 20.0, let's just assume these are all 3 significant figures, because I did not fix those for some reason. Okay, I'm going to give you time to try number 1 on your own, and then unpause the video and see if you did it right. It says, what temperature is needed to change 16.4 milliliters of a gas at 28 degrees Celsius to 20 milliliters? So what temperature is my new temperature if I'm changing this volume at this temperature to this new, that's a volume 2. Okay, so T2 I don't know. V1 is 16.4 milliliters. Temperature 1 is going to be 28 plus 273. And temperature 2 is going to be 20 plus 273. Oh, sorry. Nope. V2. Sorry, V2 is simply 20 milliliters. There we go. Okay, so I'm solving for temperature 2. So if I have my equation V1 times T2 equals V2 times T1, and I'm solving for temperature 2, I need to get volume 1 to the other side, so I would divide both sides by volume 1, and I now have T2 equals volume 2, which is 20 milliliters, times my initial temperature of 273 plus 28, which is 301 Kelvin, all divided by volume 1 of 16.4 milliliters. We can see if this makes sense. My volume is going up, which means my temperature would also need to go up, and so I have 20 over 16.4. That is greater than 1, so that will make 301 go up. So 20 over 16.4 gives me a new temperature of 367 Kelvin. My milliliters cancel, and that's my final answer. Okay, Let's have you try number 2. I'll give you 3 minutes, and then you can unpause.
Wait, give me around.
Probably. Let's see. It says, what new volume would 125 milliliters of a gas at 25 degrees Celsius take up at standard temperature? So I'm looking for a new volume, so that's V2. It's at this volume of 125 and at this temperature, and so I'm going up to standard temperature. So V2 is my question mark. V1 is 125 milliliters. Temperature 1 is 25 plus 273. And temperature 2 is actually lower, it's going down to 273. So my initial equation of V1 T2 equals V2 times T1. I'm solving for volume 2, so I divide both sides by temperature 1. So I end up with my initial volume of 125 milliliters multiplied by my new temperature of 273, which is less than 273 plus 25, which would be 298. So this should go down. So 125 times 273 divided by 298. Yes, you need to round. We're going to keep 3 significant figures, so this would be 115. Kelvins cancel. This is milliliters. So my calculator gave me 114.5, but since I said to just keep 3 significant figures, we're going to keep 115. Okay, good job. Let's keep trying. Pause the video, try it yourself. Okay, number 3 says, what new volume would 300 milliliters of a gas at 0 degrees Celsius take up if the temperature increased to 30? So my temperature is going up. I would expect my volume to go up. I'm looking for my new volume. My initial volume is 300, and it's at a temperature of 0 degrees Celsius. So I'm going to add 273 to that, which is 273 K. And then my new temperature goes up by 30. So 30 plus 273 is 303 Kelvin. So there's my variables. Now I'm going to use the equation. V1 T2 equals V2 T1. I'm looking for volume 2. So to get T1 to the other side, I divide both sides by T1. So now I have volume 1 was 300. And I need it to go up. So it makes sense that my 303 Kelvin is on top over the 273 because that's greater than 1. So 300 times 303 divided by 273. And I'm keeping 3 significant figures, so that 9 is going to round the 2 up. So 333 Kelvin cancels. I'm in milliliters. Okay, I know some of you were working ahead, so just keep going. If you really do get done, you can start the self-test while you're waiting for me to solve the questions. Okay, it says, what temperature would be needed to change 25 milliliters of a gas that's already at 100 Kelvin to 50 milliliters? So I'm looking for a new temperature. I have a volume and a temperature, and I'm changing it to a new volume of 50. So T2 is what I'm looking for. Volume 1 is 25 milliliters. Temperature 1 is 100 Kelvin. I don't need to change it. It's already in Kelvin. And volume 2 is 50 milliliters. So V1 T2 equals V2 times T1. I'm trying to solve for T2. So I would divide both sides by the volume 1 to move it over. So I have volume 2, which is 50 times my initial temperature of 100 Kelvin and the volume 1 of 25. I can see that this is going to work out because my volume goes up, which means temperature should go up, and 50 out of 25, that is double. So you should be able to realize that that's simply going to double because 50 times 100 is 500,000, divided by 25 is 200. Okay, one more. Go ahead and pause the video, attempt number 5, and then unpause it when you're ready. Okay, question 5 says, if a gas was heated from 300 Kelvin to 400 Kelvin, and now it has a volume of 10 liters, what was the original volume? So it's going from 300 to 400, so temperature 1 and temperature 2. It now has a volume of 10, so that's volume 2. Original volume would be volume 1. So the order of the sentence is backwards. So volume 1 is what I'm looking for. Volume 2 is 10 liters. Temperature 1 was 300 Kelvin. And temperature 2 is 400 Kelvin. So if temperature is going up, I would expect the volume to also go up. But at this time I'm solving for V1, so it would be lower, right? So V1 times T2 equals V2 times T1. I'm solving for my original volume. So I'm going to divide both sides by T2. So notice I end up getting then the opposite, where there's 300 on the top and 400 on the bottom, which is less than 1. It's going to make it go down, which makes sense. My second volume should be bigger than my first volume, so this has to go down. So I have 10 times 300 divided by 400, which gives us a volume of 7.5 liters. Okay, thanks for following along. Let me know if you have questions or need tutoring.